We are ready to calculate correlation using SPSS. And in order to do this, we're going to use the same data set as we used for our scatter plots. It's jobsatisfaction.sav. The same 200 counselors, the same variables at play. We are going to correlate three variables: job satisfaction, burnout, and compassion, and then we're going to examine the output. So let's switch over to SPSS. I think you will find that conducting a correlation in SPSS is quite simple and straightforward. As always, we're going to start with the Analyze menu. So choose Analyze, Correlate, Bivariate. Bivariate meaning two variables. We are interested in three variables: job satisfaction, burnout, and compassion fatigue. The abbreviations for those variables are here in the variables box. However, if we wanted to, we could either click on the Control key or right-click on the PC and show variable labels. So we just want to get job satisfaction, burnout, and compassion fatigue, get all of those into the variables box. Not many more settings to mess with. Click on Options. We're going to choose Means and Standard Deviations. Then Continue and OK. And there is our output. Pretty simple and straightforward, eh? The great thing about SPSS is it makes the calculation of a correlational coefficient quite simple. Of course, we are still left with the problem or the issue of interpreting the output. As we examine the output, we see that we are given the means and standard deviations for all of the variables, and we're given a table that describes the correlations. And the first thing I want you to note about the table is that pattern that I mentioned when we looked at the scatter plot matrix. You see, these correlations are the same. In the upper right, the negative 2.82 is exactly the same as the negative 2.82 in the lower left, because those are the same variables being correlated. So although it looks like there are 9 boxes, in fact, there are 9 boxes, only 3 of them hold any interesting information. 3 of the boxes on the diagonal are correlating variables with themselves. Any variable correlated with itself always gives us a value of 1. And that's not very interesting. The other 6 boxes are duplicates. Only 3 of them have original information. The other 3 are duplicates of the first 3. So we are only going to use 3 of those 9 boxes in our interpretation. The best way to present correlational data is to put them into a table. This table shows the correlational data for the values that we just ran. What you'll notice is that most of the table is blank, because there's really only 3 bits of data that we really need. In this table, I'm correlating job satisfaction with the other 2 variables, and you can see that for the sake of space on the top row, I've just called them JS, BO, and CF. Those abbreviations are described next to the variable names themselves. On the diagonals, where each variable correlates with itself, I put in 2 dashes, or I could have left them blank. Sometimes I've seen people put in the 1s, but I don't recommend doing that. Either leave it blank or put in the dashes. In the upper left, we see the 3 correlations, each of them followed by 2 asterisks. The 2 asterisks mean, and we can tell this from the note at the bottom of the table, that that correlation is statistically significant at the 0.01 level. Now, what you should know is that anytime you're running 200 participants with a correlation, pretty much every correlation is going to be statistically significant. So we might also want to look at the R-squared values, so we'll have a much better sense for how much variability, let's say in job satisfaction, is explained by the variability in burnout. That becomes much more interesting. So we tend to focus more on the R-squared values than the simple correlations, and of course that also depends on what we're trying to tell about our data. At the end of your notes this week, I've given you some alternative ways of creating these correlation tables. Feel free to choose the elements of the tables that work best for you and the data that you are trying to represent.